Hello. All right. I am super excited to have this session with all of you today. I'm gonna talk about how to stay calm when things go wrong in production. And I would like to start to give you some background information so that you know what you can expect from this session. The first thing is the awareness. Awareness is the key for everything, not only in system development. So I really want you to be aware of your own source code and understand the impact we make as a system developer. And the second thing is mindset, which I'm gonna reveal in a minute, that I am expecting you to have some shifts in your mind, some aha moments. And last but not least is the humanity part that we tend to forget when we work with technology. Let's start with why I am standing in front of you today. I have been working with very complex systems where we have very stringent requirements that are dynamically changing. And I got a feeling that system maintenance can be painful when you don't have the right mindset. My name is Tugce and I'm a full stack system developer at If Insurance here in Stockholm. And I have a master's degree in computer science from Uppsala University here in Sweden. And I am also a proud data tjej, meaning data girl in English language, where we encourage girls to work and study in IT, and we support companies so that they can encourage more girls in technology. I already mentioned the word mindset. What did I mean by that? The first thing is make every commit production ready. What does that mean? From my point of view, software maintenance doesn't start the moment you deploy to production. It's an ongoing process. And when I reveal my mindset, then you will have more awareness of how you can get the control of your code. But this doesn't mean that I am gonna give a recipe and then you will never have any challenges in production. There will be challenges, but when you face the challenges, you know how to identify the root cause and take the full responsibility. And last, the documentation part. Whatever we have investigated, whatever we have found out, it's very important for ourselves and for other people. So let's start with mindset number 1. Make every commit production ready. This is actually the tagline of this session. And the first question that I would like to ask you is, what is the purpose of my commit? It could be that you have fixed a bug. It could be that you have implemented a new code. Or maybe you branch your code and now you are done with your implementation and now it's time to merge back to main. Or it is possible that you have refactored the code. And that is something that I want to dive into to be able to understand for what reasons we need refactoring. I am not against refactoring, and I think it's good if we found out something that we can make it even better. But when we feel that we need to refactor, it means that we have a debt. Which means that we have implemented this code, but maybe we didn't have enough time to think through how we can implement it so that it will not fulfill today's challenges, but also tomorrow, future challenges. So the word that I want to mention here is technical debt. So let's try to understand what technical debt means. It means that it is too much complexity in the code. It's very high coupling. As we say, it's a spaghetti code that you change something here and something else somewhere else, it's failing. and it's too complex to follow the code and understand what it does. To make the things that I tell you so far a bit more concrete, let's start to look at the code on the screen. The code you see on the screen, it is a method that it has a list, and the mission is to find life purpose, and I'm looking for freedom, peace, and I celebrate, I smile, and I do a lot of funny things. And this is a real code. I just changed the variable name so that it looks a little bit funnier, otherwise it's a very boring code. As you see, you have lots of for each, lots of method calls, you have if, else. So you have everything you can imagine as a programmer in this code. So it has a lot of complexity. And the question that I want to ask here, what do we want to achieve with this code? What is the purpose? Why do we need that much complexity? How did we think when we implement this code? Is it because maybe we did the relations in the database wrong, so that we need a lot of coding? Or are we going to build a power plant or a jet fighter or whatever? Why do we need that complexity? It's just a question. And when I look at this code, actually, I got a feeling that this is a very good example to show you how you can violate solid principles. I'm sure that you have already heard about solid principles, that it will suggest you decoupling, separate things, use object-oriented concepts, encapsulation, polymorphism, and the implementation depend on the abstraction, not the other way around. And if you are interested in solid principles and how you can apply solid principles when you need to refactor your code, then I will suggest you to look at the link on the screen. This guy, he has associated the refactoring with solid principles. So when you got a feeling that you need to refactor the code, it is very possible that you violate one or more solid principles. So check it out. And the second thing is that you probably have too much responsibility in the code. So there is no cohesion. For example, if you look at the code on the screen, then you will see that this is a class that has a lot of methods and it's a human needs. It's very probable that we will extend this class because we're humans, we have a lot of needs. But instead of having too much methods with a lot of parameters, can we just use the beauty of object-oriented programming and using the interfaces and create a class instead of having things in as a parameter in the method? For example, eat. And eat is not applicable for everything. It is applicable for vegetable and fruit, but cook, for example, cook is not applicable for the fruit. So you can just decouple cook and eat so that you have two interfaces. So you don't force concrete classes to implement methods that they don't need. And another reason could be that the code you have implemented is untestable. It's a legacy code. It is working, but there is no test. So when you change something, you are not sure if you have broken the existing logic, because there is nothing can notify you that you need to fix what you have done. It is a little bit sad because you fix something, but you are unsure. But we are here to solve problems and create solutions. Just think about what logic in your system that you want to lock. what business logic you have. For example, you have a product and you have a business logic that the price of this product cannot go over, let's say, 8,000. So this is a logic that you want to lock, so that if someone else change the code, then the unit test will fail and notify you that there has been some changes. For example, if we look at the code, you just create your product and assign the price, and then you call the related methods, and then you are checking if the validation is false, because this violates the business rule. The other reason could be that you are not conforming to code standards and code conventions, and that is something that you need to discuss within your team, what code conventions we need to follow. A tips from me, for example, that the logging is really good, that you can understand if something happens and you know why this happened there. For example, if you look at the code on the screen, this is a very simple code that you add an element to the list and you are looking for a matching element. And the word that I want to attract your attention is the word first. So first means that you are 100% sure that there is a matching element in this list. If there is no matching element, then this will throw an exception. And if this code is in another loop or another method, then it will say like, no sequence found out, then you need to find the inner exception to be able to understand what list has the problem and so on. But instead of having first, if you have first or default, and then this means that I allow this to be null, and then when it is null, I will log this. And when I see this code as a developer, let's say that I haven't been in this code before and I see that this value become null, then I see that, okay, this is not something we want, but it happened, and this violates the business rule number X. Then you have a much more understanding of what you can do. Another thing that you don't have a good branching strategy. If you are using Git, then you feel that you are lucky depending on which strategy you are following. But if you use the source control in Team Foundation, and if you don't have a good strategy, then it happens that the code doesn't meant to be in production can be in production if you don't know what you are merging up to production branch. So before you commit, make sure that the code that you are about to commit is testable. And you didn't break any existing tests and the logic. And you log the necessary code. And it's always good to do self-testing. Whatever I change here, does that have an impact on the test flow checking? Is also good to be able to understand if you broke something or the whole logic still is functioning. Alright, then mindset number 2. Now we have a little bit more understanding of what we can do and how we can take precautions to make every commit production ready. And when things went wrong, then we know what we should do is to identify the root cause and take the responsibility. The guy you see on the screen, his name is Tugce. He's a Dutch computer scientist, which I would really like to share my story. When I wrote my master thesis, I was supposed to write a shortest path algorithm. And I did a lot of investigation and I found out this guy's algorithm, which is called Tugce algorithm. I read a lot of articles about this guy, and that's why I thought that it's good to share his code. And what he said, that if debugging is the process of removing software bugs, then programming must be the process of putting them in. So whatever you change can cause something different or some failure, and this is the nature of reality. This is the nature of programming. And we are here to be able to understand how we can avoid this to happen, and when it happens, then we know what we should do. So when things went wrong, the first thing we need to do is to identify what went wrong, what is not working. And then if we found what is not working, it could be a database problem, that there are lots of users access the same module at the same time, that database doesn't respond. Or it could be a network issue, or it could be your code is crashing, or it could be that you are using an external API that doesn't respond, or you have integrated code, you have other systems that you import and export data and they don't respond. So what is it? What is it? And then find the root cause. What caused this to happen? Sometimes you understand what is not working, but to find the root cause can take a longer time. And then system awareness is also important. What other systems you are surrounded by? Because if you only focus the system you are working and don't know the other systems, then this will be a problem. How your data flow looks like. What other systems you are importing and exporting data. So that you know who should you contact when another system, API or data flow doesn't working. An impact on the failure on business level is also very important. Sometimes it can take just 1 minute to fix the bug, sometimes it can take a month or a week. But what is the impact? And that's something I already mentioned at the beginning of this session. Because it's a really interesting data for us to know when we fix this, what impact we are expecting. And that's also really useful to prioritize things. And repetitive failure. Sometimes users, they live with the bugs, and we have a lot of other things, so we don't prioritize the failures. But if a same or similar failure happens, and then it will give you a message, fix me. Because I will happen again. Maybe not tomorrow, maybe not next week, but next month. So try to get the message from the failure and take the action. Whatever we found so far, that we have identified the problem and then root cause, and now it's time to bring a solution. Whatever we found should also create a solution. So whatever solution you found, bring it on. It could be that you fix the bug, but the root cause is unknown, that you need more time. Or maybe you found out both, then you guarantee that this failure will not happen again. And sometimes we don't have an answer, but we need to support the user. Then we can suggest to have a data correction and try to understand why this went wrong. And another tips I can give you is that make sure that all developers in the team can deploy to production. Sometimes a user comes to you and says that, oh, this is failing, and you just imagine that you say, okay, yeah, we understand, but the only developer who can deploy to production, he is on sick leave, so we can't help you. So just make sure that every developer who contribute to this system can also deploy to production when it is needed. And do you think that we're done here, that we did everything to prevent this, but it went wrong and we fixed this? Can we still make a difference? When everything go wrong, how can you be the person that's strong? Are you willing to go that extra mile? And what extra mile do you think I mean? Take the full responsibility and be transparent. Let's say that you have experienced an issue and say that, you know what, no users can start the application right now, and this application is used by over 400. And we have a time frame that we need to fix this until 2 o'clock. I have some ideas about what was not working, but that's the situation. I'm taking the full responsibility as a team. I'm full transparent. So let's do this. And show empathy and care to your users. Just make them feel that they are supported. For example, I work very close to my users, and when they come to me or another developer, we welcome them, we thank them that you come to me directly and say that this is not working. Just try to get the impression that you understand. I got you, I understand, and we are here to support you. And it's for the developers. Sometimes we are working under pressure. Let's face it, we have a very limited time and we need to fix problems, and sometimes it's hard for us to be able to understand how we can fix it. And just talk to that person who is responsible or who took the flag, and just say that, okay, I will fix it. Just suggest that maybe we can pair programming. Maybe we can create a small team so that we can find the solution quicker and easier. Even though this is it sounds a little bit small approach, it will make a very big difference. And get excited about failures. What? Yes, because every failure has also its own solution. And I understand that it's hard to see it from the beginning. But every failure is an opportunity for you to grow, that you are going to learn something new. You have implemented, you have written unit tests, this was tested, and it's accepted, and bam, when you deploy in production, it doesn't work. So great! Then we are going to learn something new that nobody noticed. And focus on the learning, not the failure. Because it's not important if it is my code or anyone's code. What we can learn from it. The guy you see on the screen, he doesn't have an algorithm, but he's an English film composer. And I really like his code. The only real mistake is the one from which we learn nothing. So when the first time failure happens, if you learn from it, then it's not a mistake. But if you don't learn from it, then it will happen again until you learn from it. And then it's a mistake. Because this is like this. If you don't from the mistake, then you will face it again. Or it could be like it's an happy accident. That whatever happened, it will give you an opportunity to improve your team or the way you work. If this failure hasn't happened, you will never ever notice that we need to make an improvements in a particular area maybe. Alright, So let's continue with mindset number 3. Document lessons learned. It's not good, but it's goal to know the system behavior and their production history. Because every system, even though they have similar technology, they have a different purpose. For example, a risk system needs to calculate lots of things and provide you a figure. Whereas a reporting system needs to generate a document and provide you a report. So whatever system you are working, just try to understand what is the main logic or what is the purpose of this system. And production history as well. When I start to work if I start to work with very complicated system, and when it is my turn to take the production, I experience or encounter a problem where it is very odd. I understood what it happened, but I don't understand why. And I have some findings about how I can fix it, but I was unsure. But I was lucky that we have a production history, and when I just read it through, I saw that a similar failure happened 2 years ago. And a developer has written a comment that the root cause is not found yet, it's still under investigation, but you can fix it this way. Then I feel calmer. And as I already mentioned, take lessons from the failure. Each time you face it, what lessons I learn as a developer myself, and also as a team. And share your knowledge with your colleagues, because when you share your knowledge, you empower it, you give it an energy. I learned this and I'm sharing with you, so that you also have a possibility to access this information, this knowledge. For example, I already mentioned about the operation log history. I can suggest you to have these questions when you want to write a log. What has happened? Let's say that the nightly batch failed. What did I do? Explain in detail. I found that it was not the code that is crashed, but there was some kind of a network problem in our supplier that I contact him. And he already said that they already aware of the problem and it's on their side. And he said that he fixed it and then reran the batch and then it's working. Did what I did solve the problem? In this case, yes, but sometimes no. And that's okay too, because then I know that you have tried this, and it didn't work. And then I will try to think in another way. This will make me save time, because then I will not bother myself the things that you have tried already but it didn't work. And when you make this as a habit to write things and document things, then you will feel automatically that you will figure out your improvement areas. You will have the feeling that, you know what, I have a feeling that we need to improve something in this particular area. Because when you write things down, when you document things down, then you will get much more idea about what you can improve. And whatever you document can save a developer's life and also save time. Because we learn from each other. We don't need to rediscover the wheel again. And it's always a good feeling to contribute each other's development as well. It's a good feeling. I want to contribute your development, and we as a team going towards the same goal. It's not just me who is running, we're as a team. And I already mentioned that I have a system developer with a heart. What did I mean by that? Sharing is caring. That is something that we give a lot of importance at if. Whatever you share, you empower and you contribute people's journey, people's development. And we, as I already mentioned at the beginning, we tend to forget that we work with technology to serve humanity. Whatever we do with the code and with the techniques, it's for the humanity, and we are also human and we have things in common. And strive always for positive impact, like I already mentioned. How can I make a difference? The way you approach to your users, the way you approach to the problem, the way you approach your developers, your colleagues, always make a positive impact. So, takeaways from my talk. It's scary that we are coming to end to this session. Is it? Number 1. Prod ready commits. I know what I'm doing. I took all the precautions I can. And I feel confident if I face any challenges. And number 2, root cause analysis. I identify the problem and I am investigating what has caused this problem, and I take the full responsibility, and there is no reason to blame or shame. Just take it easy and make a difference. Number 3, document lessons learned. As I said, every time we face a failure, it is there to teach you something. What lessons we can learn from it, document it, and discuss it with your colleagues within the team, or even with business. And we learn as we grow, and we learn from our mistakes actually, or with the failures. And if possible, add human essence to whatever you have accomplished. And there is one thing that I didn't reveal yet, which I keep it to the end, is to put a smile on your face, which will also make a difference. When they come to you and say that, oh, you know what, this is not working. If you say, okay, it's not working, okay, yeah. Instead of doing this, okay, it's not working. What was that? What is it that not working? How can I help you? Or it's the same when you when you talk with your colleague. Great, then we're gonna learn something new today. This will make a difference. And I want to conclude this session with a code from mine this time, that we developers, we are the heroes or sheroes of tech. So be proud of what you have done so far and what you can do even more when you have a right mindset and when you have a more awareness of what you're up to. And if you have any questions, anything, please contact me, drop me a mail. I will be here tomorrow. And relax. We will help you. Thank you.